John Mulchaey is an astrophysicist and the leader of one of the world's most renowned cosmological research facilities. He earned his PhD in astrophysics from the University of Maryland and was a graduate fellow at the Space Telescope Science Institute and postdoctoral fellow at the Carnegie Observatories, before moving into an administrative role there in 2015. As an investigator, he led the research group that revealed large amounts of dark matter in the composition of galaxy groups that improved our understanding of their structures, a major breakthrough in the field. He currently serves as Deputy for Science of the Carnegie Institution for Science and the Director and Crawford H. Greenwald Chair of the Carnegie Observatories, headquartered in Pasadena, California. In this role, he serves on the board overseeing the creation of the Giant Magellan Telescope on Carnegie's southern campus at Las Campanas, Chile. In addition to all these activities, John is also involved in public and educational outreach programs, and he's joining me today to talk about his career as an astrophysicist, the observatories, and the state of research in cosmology. This is the Bang Goes the Universe interview with John Mulchaey. John Mulchaey, welcome to the show.
Oh, thank you so much for having me. Excited to be here.
Super glad you could be on. So, when did you know you wanted to become an astronomer?
Yeah, I've been saying a lot lately that I was a born astronomer. It's interesting, if you talk to professional astronomers, there are two types. There are those like myself that were into it from a very young age. My mom recognized when I was maybe 5 that I was very interested in astronomy, and so she bought me books. I got my first telescope when I was 7, and I made a telescope. I ground the mirror when I was 12, so I was pretty hardcore. And that's the path of many astronomers. I have several others that grew up always looking at the stars and were curious. And then there's other individuals, Wendy Friedman being a famous example, our former director here at Carnegie. And Wendy was just good at math and physics, and she discovered astronomy in college, and it was just a path. And obviously it's been a great path for her. So, but I was one of those born astronomers. It's always been, I feel like this was what was meant to happen for me. So, and it's obviously worked out okay.
Wow. I should have had a mom like that. Sorry, Mom. She was really cool to me. She did the solstice every year, but the books, it could have been.
Anyway. My mom was a teacher, so she recognized the importance of books. Nowadays you don't even need the books because, of course, it's all online and there's so many ways. But
yeah. Mom did a lot of great things. No offense, Ma. You're great. Where'd you grow up?
So I grew up in Northern California, San Francisco East Bay, just kind of near Berkeley, a little town. But it's a town that's called Pinole. It's in this beautiful valley just north of Berkeley, and so it has surprisingly dark skies for the San Francisco Bay Area. And so I could see stars. And as a kid, I spent a lot of time watching meteor showers. That was one of the things that first got me into astronomy. But so I was able to at least see a lot more stars, than I can now here in Pasadena. But it helps. Not every kid has the opportunity to see stars, and it's kind of a shame.
Yeah, it really. I grew up outside of Chicago, and I kind of had a similar experience. That I grew up a long time ago on the outskirts of Chicago, and so it was much darker. I mean, we were really pretty close to rural, and I remember being amazed by the amount of stars. And I laugh at that, or I would laugh at that later on when I would, go visit with friends down, in Arizona and New Mexico. And, we'd be in the desert, and I would wake up in the middle of the night and look up and be, confused. Like I couldn't see, couldn't recognize the constellations. There were so many stars. It was just amazing. That blew me away. Okay. So you kind of spent more or less spent your life in California then, yeah?
Yeah, I did. The only time I really wasn't here was when I went to grad school on the East Coast. So, I didn't travel much as a kid. So one thing I really wanted to do was experience the East Coast. I went to the University of Maryland, which is just outside of Washington, D.C. And it was good. It's good to see a different part of the country. And so, I of course, now I get to travel all over the place. So I've been to almost every part of the U.S. now for work. But it was good to spend a few years there, but I'm happy to be back in California. I like the weather.
Yeah, for sure.
Yeah.
So your mom was probably, I guess, an early mentor. Anybody else who was most influential for you growing up?
I often, well, I'd say for me, I went to private Catholic schools, which, aren't necessarily always known for their amazing science education. But I had two really great teachers. One in fifth grade, she was just very obsessed, Mrs. Kennedy, with science, and so that was kind of the first thing that kind of really brought me to the next level. And then I had an amazing physics and chemistry teacher in high school who was a priest, actually, because it was a Catholic school. And those two teachers were really enough to kind of carry me through and, get me to, I then went to Berkeley for my undergraduate degree. But, not every teacher needs to be great at everything, of course, but having some exposure to science. I remember in fifth grade, and it wasn't even astronomy, it was, I remember we worked on snails, and we had these things where, we were watching how snails mate and various things, but it was science. It was just for a fifth grader that, you got to see it. And so that was super helpful and helped get me going. So, a few good teachers like that can really make a difference.
Yeah. One of these days, I want you to come back and let's talk about how to develop physics programs for grade schoolers, but not about that today. Because I'm very into that idea. So have you worked at Carnegie basically your whole career, or did
I have. So
Yeah.
it's interesting. I finished my PhD in 1994, so 30 years ago.
Okay.
And I came here as a Carnegie postdoctoral fellow. It's one of our very prestigious fellowships. I actually was not intending to come to Carnegie, but I didn't. I had hoped to actually go to Hawaii because, of course, the amazing skies in Hawaii. But I interviewed with Carnegie, and my interview, I was so excited with the folks who interviewed me that it completely changed my mind. And when they made me the offer, I came here. So I came here as a postdoc for about 5 years, and then I joined the senior scientific staff. And then, I was in that job for about 15 years before becoming director about 10 years ago now.
Yeah. So what in your research career, what do you think ranks high? What do you think about the most in terms of, what ranks highest with you in terms of your achievements? What inspires you most about the field, if anything, most?
Yeah, I got pretty lucky when I was a graduate student. Science often involves an element of luck, right? It was doing the right thing at the right time. And that definitely happened for me, which helped propel my career and it's where I'm at now. In 1993, I was part of the team, and I wrote the lead paper that discovered X-ray emission from a small group of galaxies. So, we had known for a long time these clusters of galaxies, these are systems with thousands of galaxies, the most massive things in the universe, had a lot of X-ray gas, and that X-ray gas is just due to the mass. The gas is heated up basically by the gravity of the mass. So we knew about that for quite a long time. That was discovered in the 60s and 70s. But what we discovered in 1993 was a very small collection of galaxies, something more similar to our own local group that we're part of. And we had an early observation with the Rosat telescope that detected that X-ray gas there. And that gas allowed us to measure the mass of the system for the first time. And it showed that there was, in fact, a lot of dark matter in the system. So it was kind of the first proof that there was dark matter in these small collections of galaxies. And these groups are by far the most common environment. So like 90% of galaxies occur in these small groups. So it was a pretty big result. I always say groups are like studying the suburbs. There's people who live in the suburbs and small towns, and the cities are the big clusters. And so, but in terms of galaxies, the majority of galaxies are actually in these small little groups. So that big discovery in 1993 put me on the map. Got me I was in the New York Times and all sorts of things. It helped give me a job at Carnegie. So that one is certainly has to rank as probably the most important thing in my career. I should say that that was a side project. My thesis was on a very different topic, and I was working with Richard Muschatsky, who's at NASA Goddard at the time, and he's now at the University of Maryland. And that was my side project. And my side project ended up being what I'm most famous for. So when I came to Carnegie, I kind of moved and worked on that topic. And that was one of the more exciting results. The astronomy always is giving you new surprises. So anytime you get anything you're not expecting, and that was something we were not expecting, it was really remarkable.
Yeah, that's the discovery, and then you never know necessarily what trajectory your career is going to go on either. That's interesting. That's we got to mark that one down too. I want to come back and talk in depth about gravity and galaxy formation, evolution. It's obviously it's a huge part of Carnegie's history,
Right.
and one of my most one of my greatest fascinations. Just so anyway, we'll get to that later.
Sure.
Yeah, the galaxy groups thing is really interesting. It was, I remember Hummus, and people probably get tired of me talking about Hummus, but he and when he was working with Hubble 100 years ago at Mount Wilson, I remember Sandage, I think, mentioned this in his Centennial Histories, and I didn't realize it until I read it. But Humison may have been one of the first to kind of bring up galaxies and groups, and now it's such a major part of the study of galactic evolution. It's pretty remarkable how things descend.
Yeah, that's interesting. So I was not aware of that. I'm not surprised.
Yeah.
There's lots of surprises as you dive into Hummus and you learn more.
Yeah, he's quite a character. Anyway, don't get me started. Don't get me started, John. Oh, I started myself. So you became director in 2015.
Yep.
What do you like most about the job?
I get to give a lot of talks on astronomy. So I should say that the one thing I had not anticipated when I became director. First of all, I never really wanted to be director; it just kind of happened. But as I don't really get a chance to do a lot of my own research anymore, that has been put on the back burner. But I do get to talk about astronomy a lot. I give a lot of talks around town. I do a lot of press. I do a lot of things like that, and I think I'm actually particularly good at that. In some ways, I think I was a really good astronomer. I'm pretty sure I was. I got a job at Carnegie, which is not a small accomplishment. So, but
No.
but I think I might be a better director, which is really remarkable because it wasn't something I expected. I think I'm a particularly good at communicating with the public. I hear this a lot, but that's an element that I think I really, really enjoy, and I had not anticipated. I mean, I was a kid who wanted to be an astronomer, right? And so I don't actually miss doing a lot of the research myself because I feel like I'm talking about astronomy every day. And I also am supporting astronomy because I'm, of course, supporting the next generation of astronomers that come through Carnegie. And so my job now is they come to me with exciting ideas and to make sure I can make those things happen. Right.
Yeah.
So it's fun. I love giving talks. I love talking to people. It's very rare you meet somebody and tell them you're an astronomer and they think that that's a terrible thing. Or it has once or twice once somebody said to me on a plane, we shouldn't spend money on that. But that's like once in 30 years. And most people go, oh my God, that's remarkable. I've never met an astronomer, right? And so there's a lot of people who are very fascinated by astronomy, and that's a great thing.
Do you find um, do you find it difficult to stay uh, at your peak of knowledge, given the fact that you're out of research, or is it actually easier because you don't have to focus on one field of research? You can kind of back up and consult with people who are exposed to various parts of the field. How's that working out for you?
That's a really interesting question. Because you're right. I mean, I think when I give talks, I talk about lots of things. I talk about exoplanets. I've never worked on exoplanets, but I talk about them a lot. I talk about neutron stars and black holes and things I haven't really worked on, right? But I'd say, my knowledge is probably at a very high level for those things because that's all it needs to be for the job I'm doing. It is interesting. Sometimes I don't unfortunately get to go to a lot of our professional colloquia, but when I do, it's remarkable because I'm like, wow, I had no idea we could do that now because things have just changed. The technology's gotten so much better that there's a lot of things that 20 years ago I would have dreamed of doing as a scientist that you can now do. And so a lot of that, I don't read the Astrophysical Journal, every page of the Astrophysical Journal, which at one point, in my career, I would have read a lot of that. I don't do that. So I know a lot over a very broad range, but it's not at a very deep level.
Okay.
But that's okay. Once again, for
Interesting.
my
Yeah.
job, it's fun. Yeah.
Yeah, for sure. For sure. Um, Care to comment on what you like least about the job?
Oh, well, of course, any job when you're managing comes with people, and generally people are great, but the people problems are always the most challenging. And I'll just say, scientists can be particularly challenging. I work with some of the most brilliant people in the world, right? And the problem is often they think they're the most brilliant people in the world, and so sometimes there's a disconnect between, they have a hard time understanding that they could possibly be wrong, or that they're not understanding why we're doing something in a particular way. And so I think that sometimes is the biggest challenge, but for the most part, it's not too bad, but that does eat up some time.
So it's still people. Okay.
It's
I
always
remember
people. Yeah.
another Humison anecdote when he talked about, having to do the scheduling on the mountains back in the day. And the guys would come to him and complain, and he would say, okay, starting next week, you're in charge of scheduling.
I should say that we've had one guy who's done our schedule here at the observatories the whole time I've been here. His name is Ian Thompson. And he's close to retirement age, and everybody's very panicked about that because it's a job that's a terrible job. A terrible job
Tough
to have to
job.
schedule a telescope, right?
Yeah.
And we have a lot of telescope time at Carnegie. Everybody does okay, but you don't always get what you want, right? And so people don't like that.
Yeah. Yeah. Great. Well, you seem like you're bent on paying it forward. I have to read this. There's so much. In 2020, you were awarded a Helios Award from the Rotary Club of Sierra Madre for your efforts in promoting and sharing your experiences in astronomy with people of all ages. You created the popular observatory's astronomy lecture series at the Huntington Library in Pasadena. It's now more than 20 years old, I guess, and features Carnegie scientists and discussions of various aspects of astronomical study. You give you've mentioned this earlier, as many as 50 talks a year to groups around the country. You launched a program for high school students with special interest in facility with math and science to offer them greater exposure to the field. You host star parties and open houses. Where does all this outreach come from? Is it part of the job, or what motivates you?
Yeah, no, so it's super important to me. It's super important that we do that. I should say that, of course, there's lots of people who do help with that stuff now. At one point, if you could rewind maybe 20, 25 years ago, Carnegie really wasn't doing any of those things. And a lot of those I did start. So I was very interested. I had been working in the schools even back in the 90s. My mom was an educator. When I was in high school, my mom would bring me back to talk to her fourth graders about science. Because it turned out my mom, even though she recognized that I was into science, hated science. She just did not understand it. So she would bring me in to teach it. And so I think I've been involved in that from a long time. And I think it's super important, right? It is important to pay it forward, as you've said, right? And I realized that for me, I had a mom who recognized that I was interested in this, right? Not everybody has that, right? And also, not everybody understands the careers associated with science, and it doesn't necessarily mean astronomy.
Yeah.
I've been saying a lot. I said this a lot because I did a lot of press around the April 8th, 2024 eclipse. I kept saying the world doesn't need 1 million astronomers or 1 billion astronomers, right? I mean, it's a pretty small profession, and that's fine. And I think we can certainly justify having a number of us working on this. It's worth mankind to do that.
Sure.
But we do need technical people, right? We do need computer people. We need people in all sorts of other chemistry, physics, all sorts of other fields. And so astronomy is a great way to get kids interested in science, I feel, and hopefully get them, send them on paths that could send them to careers in science and technology. And one thing we find from the star parties particularly, often the parents have no idea that there are options for their kids. And so, I've had parents come up to me and go, my daughter's really interested in astronomy, but I need her to find a job and, make money. And I'm like, well, do understand that if you have a PhD in astronomy, even if you're not doing research in astronomy, you're extremely employable. It's almost 100% guaranteed that places like Google and Apple love the technology that and the way our minds work as astronomers. So don't worry about her employment, but, more important, she should be able to pursue what she wants to pursue.
Sure.
And so I feel like one of the reason this outreach is important is I think it does expose kind of the next generation of children to, careers in technology, which is very, very important. Yeah.
Yeah. Love that. Love that. All right, let's move to the observatories then. Obviously there's a lot of excitement around what's going on in Las Campanas down in Chile. There's still a vibrant organization in the north, however. What's going on between the two? What are the differences? What are the similarities? What excites you about what's going on?
Sure. So I should say that, I use all those facilities, or I have in my career. I've observed at Keck and Gemini North and a lot of those telescopes in the north. I did half of my thesis was done at Kitt Peak. So, half of it was done in Chile. So, there's a big sky with lots of interesting objects. I think
Yeah.
the big thing now, as many people will know, is, we're at Carnegie and other partners, we're trying to build the next generation ground-based telescope at Las Campanas, the Giant Magellan Telescope. And then our colleagues at Caltech and UC in the US, along with international partners, are trying to, of course, build the next big telescope in Hawaii called TMT, the 30 meter. And, they have some challenges on the mountains people are probably aware of. But the US community, in our decadal survey back in 2020, ranked these two telescopes as the top priority for astronomy. And their idea was that we really would like the National Science Foundation to participate in both of the telescopes to give access to pretty much all US astronomers to both the north and southern sky. And I think there's a lot of reasons for that's super exciting. One, the Europeans, our main competitors are the Europeans at the moment. They have a telescope in Chile. It would be amazing.
Yes.
But it would be terrible for US astronomy to turn our back on big glass, because we have the tradition. The US has been leader of this,
Yes.
going back to Lowell and Lick and Mount Wilson. I mean, right? So for well over 120 years now.
Yeah.
And so we really
Yerkes.
Yerkes, yes. So we absolutely all these play right. I mean,
Yeah.
really, the US has been the leader in ground-based astronomy for certainly the last 100
Yeah.
years and longer. And for that to maintain, you really having access to both telescopes would really be critical, I think. There are interesting objects in the north, there's interesting objects in the south. One could argue you only really need one. The real reason to have two telescopes is that means you have two telescopes working all the time, right? You're collecting different data. And they also have very different instruments, different capabilities. And so the more capabilities you have, the more sorts of science we can support. So right now we're spending a lot of effort to try to, bring that forward and putting pressure on the National Science Foundation and Congress to keep us as the leaders in ground-based astronomy.
Right. Yeah. And these are optical telescopes too.
And these are optical telescopes, yeah.
Right. So
still in the infrared, but mostly optical.
yes. Right. Yeah, I did see that. Yeah, fascinating. I mean, Keck is still one of, if not the most widely used optical telescope on Earth. It's still, I mean, an incredible piece of machinery. I've been up there and fascinated by that telescope.
So yeah, there's a number, I mean, the Europeans have one, we have two in Chile.
Yeah.
There's about a dozen such big telescopes in the world, and they are all working at maximum capacity. I mean, there is no lack of amazing things to do with those telescopes.
Yeah.
Keck has been around 30 years now. And so they probably have 20, 30, 40 years more on those telescopes. And so, I mean, I think the thing is, a telescope, once you've built it, it can last a really long time. If you're continually updating the instrumentation, they can be very relevant for a long time.
And that instrumentation was always important, but these days there's so much technological advancement all the time. I think they were making them then, but it was more specific. I mean, you were emulsification was, one of the things that was being developed, and better prisms and things like that. I mean, these days with adaptive optics were a big thing with the Keck, and now that's even been developed so much in the last 30 years. You do have to keep up with it, but it's easier to do once the thing is made. The hard part is get it made. I mean, right? I mean, that's yeah. And these things are extremely expensive and cumbersome to build.
That's right.
Yeah.
Yeah.
Fascinating.
No, it is. I mean, they're expensive instruments. The thing is the good thing is once you have a telescope, it's used by many, many astronomers. So, I have colleagues who work in biology, and in biology, it's all about your lab and all the people in your lab and everything. And so every time we hire a biologist at Carnegie, we're setting up a whole new lab for them and all those people. When we hire a new astronomer, I'm like, everybody's using the same facility. So it's kind of a different model. It's just different to see how the different sciences work, right? And so, but yeah, these telescopes, there's no lack of good projects to do on those telescopes that are now 20 and 30 years old. It's hard to believe they're old, but they are.
So is the Northern Campus just on Hawaii these days?
Well,
in terms of optics, in terms of what you're seeing.
I would say that in terms of the most important site certainly has got to be Mauna Kea. If you ask the best places to do ground-based astronomy in the world, Chile would almost certainly be number one. I might be biased, but at some point, I think within 10 years, 80% of all telescopes will end up in Chile. So Chile's really kind of viewed as
Yeah.
number one. But Mauna Kea is certainly by far the best site in the Northern Hemisphere. There are others, the Canary Islands, obviously still some telescopes in Arizona as well. People have been looking at Baja, California. So there's some other places, but
Hmm.
Mauna Kea is pretty unique. And of course, the
Yeah.
height, the elevation of Mauna Kea really is helpful.
It's
Quite a bit. Above a lot
incredible.
of
Yeah. Yeah. I mean, you just the reduction in turbulence is amazing there. It cools off so much.
it
And you
does.
have so much circulation. It's got to be helpful.
Yeah, no, it's an amazing site. Like I said, I've
Yeah.
been there many times too.
Yeah. Yeah.
Chile, we just have so much. The weather statistics in Chile are just unmatched. I mean, it's clear like at our observatory 90% of the time or something. And we have Las
Wow.
Campanas. We are actually, I argue, has the best statistics for seeing. That is, the image quality on Earth.
Hmm.
We have
Hmm.
40 years of statistics, and it is a remarkably good site, even better than the other ones in Chile. So, you
Yeah.
know, these places are pretty special.
Yeah, for sure. I won't mention the other ones for Carnegie's sake, but they're great. They're
They're all
doing
great.
good
Yeah.
work all around, all around. Everybody's doing good work. I want to get down there one of these days.
Yeah.
Um, so okay, and I was asking that question because the Santa Barbara Street still has, I don't know if it looks like it's not necessarily an engineering department, but there's definitely a workspace in the back
Yeah.
and ongoing work being done on something. So are there, when you hire somebody, for instance, as who's more biology based, are they working at the offices there, or is there some other?
Ah, no, they're in different locations. So in fact, we're
Gotcha.
in the process of right now, they're not even in Pasadena, but we are in the process of moving them to Pasadena, which should be exciting.
Mhm.
Um, the workspace you're referring to is, I mean, we have a lot of engineers. It's actually, in fact, I'll have to have you come by next time you're here because we've had a lot of growth in the last since the pandemic. Because right now we're building a lot of things. So I'm continually hiring
Oh,
new engineers, and we have
yeah.
a machine shop. Actually, right now we're kind of packed in on space because we have so many projects going on. We have a couple really amazing instruments. One called Mirmos that will allow us to study atmospheres of exoplanets in real detail.
Wow.
And so we're super excited about that one. There's another one called VIA, which is going to be probing dark matter in a unique way in the halo of the Milky Way. I'm super excited about that. So yeah, we're building a lot of stuff. There's a lot of interesting experiments going on.
I can't believe dark matter is becoming a reality. That's the way it is. It's just amazing that that's happening.
Yeah.
Bravo to you guys for discovering that. Okay, great. That's very informative. I definitely will stop by probably in the fall
Nice.
and we can chat about that. But I can't have a discussion with John Mulchaey, director of the Carnegie Observatories, without talking about the GMT project. How is
Sure.
it coming? I understand the seventh mirror was recently cast. There are only seven mirrors, so we got to be getting somewhere. One of the things I wanted to ask you was where are the mirrors being cast?
Mhm.
And then is this stuff moving to Chile immediately, or are you going to move the whole thing all at once, or how's that working out? These things are incredibly heavy.
They're huge. So the mirrors are being made by our partners, the University of Arizona.
Okay.
They have kind of a very unique, and they're really the only place that builds mirrors quite the way we do. And they built the mirrors for our Magellan telescopes in Chile already. And they build them in a facility that's under the football stadium at University of Arizona. It's an amazing
What?
place. Yeah. Well, it's just a lot of space under there, and they took advantage. And so the mirrors we're making really great progress on. As you said, we just did the casting for the seventh mirror. The casting is the first step. Typically takes 2 or 3 years for a mirror to go from there all the way through to the end. So we have a number of mirrors are done. I think maybe 3 are completely done on 4, 5, and 6. Mirrors 4, 5, and 6 are at various stages, with 7 kind of right at the beginning. So the
Mhm.
mirrors we're making great progress on. The telescope mount, which is the structure that holds all those mirrors, which is pretty substantial, is being built right now by a company in Illinois. So that's going on as well. So
Oh,
that's exciting. Yeah.
Nice. My
We're
home state.
Yeah, there you go. So that's also worth visiting. So that's an amazing facility there.
Mm.
And then and then there's progress being made on the various instruments that are those are kind of being done all around the country. Here at Carnegie, we're building the first camera for GMT. So you need a camera to help align the optics of the seven. So we're calling this the commissioning camera because it will be used to get the telescope aligned initially.
Uh-huh.
However, it will
Nice.
also allow one to take beautiful images with the GMT. So it will be the instrument used on the GMT. So
Oh,
we're
that's
building
great.
that here in Pasadena. So there's a lot of progress here. The thing we're still waiting for is the National Science Foundation to come in with some funding. We do need funding to close our fund. We have a funding gap. I mean, these telescopes are large, very, very large. The GMT is something, the dome is like 24 stories high or something. I mean, it's incredibly large. I
Amazing.
think people understand just how big they are. And so they're expensive. They are very expensive.
Yes.
We've raised a
Yeah.
lot of money for GMT, but we still need some more. And so we're knocking the doors at NSF and hoping we will get an answer in the next few months about funding for it.
Definitely need to get it. What about down in Las Campanas? So I imagine you've broken ground.
Oh yeah,
But yeah, and
thank you. Yeah.
dome is being built, or where are you at?
Well, so thanks for pointing that out. So we actually have the site has been excavated for a few years, and we now have completed the hole, which will be cement fairly soon, which then the whole thing will go from there. So yeah, so that work has happened. We got a little delayed because of the pandemic. Of course, like many things that unfortunately cost us a couple of years in reality. Every time things were really good in the US, they were bad in Chile because of the opposite hemispheres with
Yeah,
COVID.
right.
It was almost exactly the opposite for a year or two. But we're finally up and running again. Yeah, so the site's ready to go.
Wow.
And yeah, so we'll
The
start.
structure's got to be massive to hold
Yeah,
this thing.
it's incredible. I mean, this is the thing. The companies that we're talking to build the dome. These are the places that build the giant stadiums. I mean,
Yeah,
there's certain engineering you need to be able to do. But I always
yeah,
remind people, it is like building a stadium, but it's also a stadium that rotates, right? And
right.
points. I mean, it's not a static structure. These are
No.
incredibly challenging. And in Chile, we of course and in Mauna Kea too, but in Chile, we're very worried about earthquakes. So you also have to design the telescope to withstand, we're at least a 9.0 earthquake is what we're
Oh my
aiming for.
God.
So you can
Oh
imagine there's
man.
a lot of engineering that goes about in these systems.
Yeah, that's interesting though. You pointed out that you go to engineers who are familiar with building on such a grand scale, which is part of the history also. I mean, you go back to Corning and the 200-inch mirror and Saint-Gobain back in the 19th and
Yeah.
early 20th century. I mean, these were the people who knew best how to either cast a mirror, and they struggled a lot to get it together back then. But I mean, of course you would do that. Westinghouse building.
Mhm.
Yeah. Anyway, that's
Yeah.
fascinating stuff. Wow, that is really exciting. What is the proposed date at this point? I know the needle keeps moving for seeing first light. And what's exciting you most about when you think about the GMT getting in the saddle there to look with that thing? What's exciting you most with that?
Yeah, so our hope is that we'll be online around 2030. And these telescopes, all of them, all these big telescopes, are probably going to take some time to get them really. I mean, they're very complicated things. It's not like you just point and it's ready to go the first night, right? So the
No.
question is, how long will it take? But once it gets going, I think one of the very exciting things, of course, is studying the atmospheres of exoplanets. So James Webb, which is a remarkable instrument, is doing some amazing work. People have probably seen some of the beautiful spectra from, they're seeing water and carbon dioxide in exoplanet atmospheres. The challenge is James Webb is a pretty small telescope compared to GMT. And so a lot of the planets that we're able to observe with GMT are large planets. They're Jupiter or bigger in many cases. And
Right.
so, of course, what we really want to see is we want to study the atmosphere of the planets that are more like the Earth, right?
Right.
Those are very, very hard. And James Webb just really doesn't have the capability. It's too small a telescope. So
Yeah.
GMT will be able to do that. So to me, kind of the obvious primary driver for GMT at the moment is looking at exoplanet atmospheres around Earth-like planets. That's going to be super exciting.
Yeah.
I should also say that James Webb, of course, works in the infrared, which is great because there's water and carbon dioxide. But really, one of the elements we're most interested in is oxygen, molecular oxygen, because we think that's a really, probably, I would argue, the most important biosignature. So if we want to know if, on Earth, the oxygen in our atmosphere has come from plants. So if there was no plant life on Earth, we wouldn't have oxygen in our atmosphere.
Right. Right.
So you can imagine us wanting to do that same experiment, and we will, looking for places where there's oxygen in the atmosphere of exoplanets. And James Webb can't do that. It's not in the right wavelength range.
Yeah. Right.
GMT will. So that's one of the first things these big telescopes are going to be used to do is to really study nearby planets.
Yeah. And you could never do that in space. I mean, you can never get anything remotely close to the size of these beasts.
Not in a realistic,
not now, anyway.
Yeah, not in a realistic sense. So, people are already talking about the follow-up to James Webb, or actually really more the follow-up for Hubble, which would be something like a 12 meter, so about twice the size of James Webb. And that already at the earliest is like 2055 or so. And honestly, that's even unrealistic. So for me, given my age and given this, I wouldn't pin my career on it, right? But to go to the next stage, maybe at some point, you'll be able to do it, but not in a realistic time scale.
No, I mean, I just, these things may get done eventually. I mean, that's the whole idea here, is to keep advancing. But it's just stunning the degree to which these big optical land-based and the radio telescopes too are able to zero in on things that the space telescopes, although they have the advantage of darkness, they can't. They just don't have the light gathering capability. So it's super necessary. I think this is maybe what we're getting to when we're talking about the NSF and funding, is this isn't just a silly project that, some science kids, some advanced science kids want to get together. This stuff is really important and will help balance out the information you're getting from James Webb and from Hubble and from Gaia and from all of these other telescopes that are out there studying different parts of stellar and exoplanet exploration for these various signatures that are so helpful and useful in understanding what's going on out there. It's really important that people understand that, I think.
Yeah, I actually appreciate you saying that, because it's recently I spoke with Dennis Overby at New York Times. He had an article on the two big telescopes. And a lot of the comments I always go to read to see what people say. And a lot of people were like, why do we need these? We have James Webb. So we clearly do need to, I keep arguing that James Webb makes the case for GMT even better, because you're seeing see what we've learned with James Webb, but think about things we can't do. And so that's why you do really need this next generation telescope. And I also do want to remind people they're a lot cheaper than the space telescopes.
Yeah.
Webb it's made, once again, I won't say anything negative with James Webb. It is
unbelievable.
And many of my astronomers are using it. It was $10 billion, where the GMT will be a quarter of that probably in the end. And so, there are still a lot of advantages to being on the ground. But the big one is if we really want to answer some of these fundamental questions in our lifetimes, it's the only thing we can do.
Yeah. What, 4 times the resolving power or something of James Webb?
4 times the resolving power, 15 times the collecting area.
Yeah.
And the other thing, of course, from ground-based telescopes is you can change the instruments. We talked earlier about technology.
Right.
As technology improves, we're going to be able to put better and better detectors, better and better spectrographs on the telescope. That's something you really can't do in space.
Yeah.
And that, so there, in some sense, James Webb is great, but it's going to be stuck in 2010 technology for many years. Where
L2, baby. That's out there a ways.
Right. That's right.
I mean,
it's the cost you have for L2, right?
Right.
And I mean, the reality is, all these things are important, but I do want to distinguish that there's a great argument for these big telescopes.
Definitely. And everybody, whoever can build one. I mean, I understand Owl's not going to get done. That thing's ridiculous. But
yeah, that was probably too big of
that was too big a chunk.
Yeah.
And that's a Carnegie thing too. I mean, they started off, I think the 200-inch was supposed to be 300 inches originally.
It happens all the time. Yes.
Yeah. I mean, come on. Eyes are bigger than the stomach, or the wallet.
Yes.
fascinating. I could just talk to you all day about that. But I'm really, really excited to hear about the seventh mirror. That's a big step, and that things are moving along down there.
Yeah.
That just sounds really promising. I know TMT, it's really held up there. I don't want to step on anyone's toes. I understand, people's various biases, and it is difficult, but I hope that they're able to get that done too, because north and south, you're looking at different things, and it's all helpful. So hopefully it gets done.
Right. Yeah, I mean, so one argument for having both the northern and southern sky is that there's probably only a handful of Earth-like planets in the entire sky that will be close enough to study, even with these big telescopes. So while GMT will certainly have access, maybe there'll be 5 to 10 of them, there'll be some that'll be far north that we won't be able to see. And so for very rare occurrences, having all sky is super important.
Yeah.
People may remember the 2017, the neutron star merger that was discovered with gravitational
Right.
wave. That was actually, the optical light was found at our Las Campanas Observatory first in Chile. That was, for instance, it was really almost invisible from Hawaii. It was right on the horizon. And, imagine if a super important supernova, imagine the first supernova in the galaxy we find in 400 years happens in the northern sky, and you don't have access. That would be terrible.
Right.
So I think
Yeah.
there are arguments for doing both the north and the south.
There definitely are. Whatever. I'm one who's very fascinated by this stuff. I have zero. I'm all go all the time. Obviously different people have different ideas, and we do have a lot of problems here on Earth,
Right.
but
We do.
we can answer some of them by knowing what else is out there.
Yep.
So anyway, all right. So what price? I just want to ask this question and kind of get your final thoughts on programming for youth, because as I said earlier, it's kind of an important part of why I'm doing this series. What programming is available for young people? I know you mentioned the high school project, but young people who seem like yourself, who seem like young astronomers from an early age. Are there programs out there? I guess maybe you have to talk about the state, but if you know any nationally or even internationally that you want to talk about, I'll give you the final word on that.
Yeah, I mean, I think, well, the answer is, of course, it does depend somewhat on where you live. First of all, I should say that parents can do a lot on their own. You can still buy books. You can still find lots of local resources. It's pretty simple. And places like NASA and the National Science Foundation actually have remarkable websites with lots of education activities. So there's lots you can do there. But of course, for most people, the best option is to find what your local city has in terms of museums. So here in Southern California, we have the California Science Center, for instance, an amazing one. When I was in the Bay Area, Exploratorium was one I used when I was a kid. We just did, for the eclipse, we were in Dallas, and they have an amazing science museum we partnered with called the Perot Museum of Science and Technology.
Yep.
All these places have so many places for people to take their kids. So take your kids there and find out, one of the remarkable things is these museums are very hands-on now. It used to be very stale, lots of reading and stuff. Now they really have it to be very interactive, which is really, I think, a better way to engage kids and get them a little more interested in kind of how science works and, what it would be like.
Awesome. John Mulchaey is the Deputy for Science of the Carnegie Institution for Science and Director, and Crawford H. Greenwald Chair of the Carnegie Observatories, and sits on the board for the development of the Giant Magellan Telescope at Las Campanas, Chile. John, thanks so much for coming on the show. I hope you come back and talk with me again.
Always happy to do it, Ron. Thank you so much for having me.
That concludes this episode. I hope you've enjoyed it. Remember to like or subscribe to the show for updates on future episodes as they're published. We really appreciate the support. If you have questions or comments about or for current or future episodes, please leave them in the comments section or email them to me at contact@ronvoller.com. Bang Goes the Universe is written, produced, and hosted by me, Ron Voller. Thanks to Mark Baller for providing the theme music. We'll see you next time.